Hello, let's move to the today's problem, special array 1. An array is considered special if every pair of its adjacent elements contains two numbers with different parity. That means every pair in the array, which constitutes of two elements, the both elements should be either one should be either even or other should be odd, or the other way, like one should be odd or the other should be even. So let's take this example. So 2 1, 2 is even and 1 is odd, so it is fine. 1 4, 1 is odd and 4 is even, so it is fine, no problem. So this array will be a special array. So return true and move to the next second example. So 4 3, 4 is even and 3 is odd, fine. 3 is odd, 1 is odd, so that's a problem. So return false. So this is the problem statement. So now what we can do? So the first approach would be like we can iterate through the full array and check all the pairs in the array. If they both return if they both are even or they both are odd, then we should instantly return false. Otherwise, in the end, if there is no problem at the end, we should return true. So now I will discuss the code. So the first line of code is finding the size of the array, simple. And now I will iterate through the entire loop. I will start from 0 till n minus 1. Means for a sample array, I will iterate only this much because I've taken I plus 1, used I plus 1 like this. So if I find two elements which are both either even or both odd, then I will return false. So we can consider this case. So let's consider this case 4 and 3. And 4 modulo 2 will return 0 and 3 modulo 2 will return 1. So these are unequal. So the if condition will not hit and it will not return false. So let's move to the next second. So 3 and 1. 3 modulo 2 will return 1 and 1 modulo 2 will also return 1. So we have to return false because this is not the criteria for a special array. So if nothing goes wrong, then this loop will execute quietly and it will not return false at any point of time. So we will simply return 2 in the end. So this is the first approach, that is very simple. So now we will discuss the approach 2. Let's try to run the first approach also. I will comment out this code and I will submit this. Let's see if it runs. Yeah, it's fine. So now let's discuss the approach 2. I've written the approach 2 here. So now let's see the second approach to this problem. The second approach will be simply just checking the binary representation using binary magic. And so simply I will try to iterate the loop from 0 to nums.size minus 1, which for a sample example it would be like 431, and I've used I plus 1 somewhere. So I will do one simple thing. So first I will explain your concept. The concept is this: if I write 4's binary representation, it will be 100. 2's binary representation, it will be 106. Binary representation, it will be 110. And 3's, these were all odd numbers, and these are some even these were all even numbers and these are all odd numbers. So if I write the binary representation of 3, it will be 11711. So I can see a pattern over here. The pattern is for every even number, the binary representation will end with a 0, you can see, and for every odd number the binary representation will end with 1. So I can do one thing. I will just do a AND with 1, and if they have the same last digit, say if they both, after doing an AND with 1, they return 1, means they both were odd, then return false. And in the other case, if they both, after doing AND with 1, they return 0, means these both numbers, the pair of numbers, were both even, then I will again return false. And if there is no problem and it runs smoothly, and if this if condition never hits, then I will simply return true at the end. So that's it. So I will try to run the second approach code also. So let's submit it. So that works fine. Thank you so much.